Hai, Assalamualaikum. We meet again. In part 2, kita akan tengok on the weighted moving average. Okay, just now we look at the moving average. Now kita akan tengok on the weighted moving average with MAD. Kita nak kira error. Okay, mula-mula kita akan buat teknik forecast and then kita akan tengok the measurement of error. Lagi kecil error is the best.
Welcome to this forecasting tutorial on weighted moving averages. We will be calculating weighted moving averages. We will also be comparing error measures using the mean absolute deviation MAD. We will be using this time series data from 7 weeks of sales. And we want to forecast sales using 4-week weighted moving averages with weights 0.4, 0.3, 0.2, and 0.1. In practice, the weighted moving average is usually employed when there is a need to place more importance on some periods over others. In most cases, we place more importance on more recent data. Therefore, in this exercise, the 0.4 weight will be placed on the most recent value, the 0.3 on the next most recent, and so on. Let's now calculate 4-week weighted moving averages using the given weights 0.4, 0.3, 0.2, and 0.1. Since we're computing 4-week averages, we start by using data from the first 4 weeks to compute the moving average forecast for week 5. So F5, that is forecast for week 5, equals 0.4 times 45. Notice that 45 is the most recent value, plus 0.3 times 40, the next most recent value, plus 0.2 times 44 plus 0.1 times 39, which gives 42.7. For week 6, the weighted moving average is F6, which equals 0.4 times 38 plus 0.3 times 45 plus 0.2 times 40 plus 0.1 times 44, which gives 41.1. For week 7, the weighted moving average is 0.4 times 43 plus 0.3 times 38 plus 0.2 times 45 plus 0.1 times 40, which gives 41.6. And the forecast for week 8 is 0.4 times 39 plus 0.3 times 43 plus 0.2 times 38 plus 0.1 times 45, which gives 40.6. Next, we calculate the mean absolute deviation for this model. First, we calculate the absolute errors, that is the positive difference between the actual and forecast values, and then average them. There are no errors for weeks 1 to 4 because there are no forecasts. For week 5, the absolute error is 4.7. For week 6, it is 1.9. For week 7, it is 2.6. The mean absolute deviation, MAD, is the average of these errors, which gives 3.07. Now, note that in this first example, the weights added up to 1. Let's look at the next example where the weights do not add up to 1. Forecast sales using 2-week weighted moving averages with weights 3 and 2. In this example, we're calculating 2-week moving averages where the weights 3 and 2 add up to 5 and not to 1. So, in calculating the weighted moving averages, we multiply the sales values by the weights as we did before, but in this case, we also divide by the total weight, which is 5. And so, the forecast for week 3, F3, is 3 times 44 plus 2 times 39 divided by 5, which gives 42. For week 4, it is 3 times 40 plus 2 times 44 divided by 5, and that gives 41.6. For week 5, it is 43. It is 40.8 for week 6. And for week 7, it is 41. And finally, for week 8, it is 40.6. Next, we calculate the mean absolute deviation. The absolute forecast error for week 3 is the absolute value of 40 minus 42, which is 2. For week 4, it is 3.4. For week 5, it is 5. For week 6, it is 2.2. And for week 7, it is 2. On averaging these 5 values, we obtain a mean absolute deviation of 2.92. Now let's compare the error measures. The MAD was 3.07 using the 4-week moving average method with weights 0.4, 0.3, 0.2, and 0.1, and the MAD was 2.92 using the 2-week weighted moving average with weights 3 and 2. Since the MAD is an error measure, smaller MADs produce better smoothing of the data. Therefore, using MAD, the 2-week weighted moving average method produced a better forecast.
Okay, so it means that when you compare these two, you will choose the smallest one, in which the best one is the 2.92, because in error, we want the smallest as possible, okay? So, do you aware that the first one, they use 4 weeks, so they have to give us 4 weights. So in this case, we have 0.4, okay, we have 0.3, 0.2, 0.1, and we need to sum it first. Since it's summed to 1, so during the calculation, he just divided by 1. He doesn't show it, okay, at the beginning. And again, if 4 weeks, we cannot have forecast data for week 1, 2, 3, or 4. But we only start at week 5. Okay. So, the error pun, kalau tak ada actual, tak ada forecast, you tak boleh dapat error. Dia kena ada dua-dua. So, in this case, the error only start dekat mana? Error dia only start dekat sini saja sebab ada data ni. Kalau yang atas ni tak ada data untuk forecast, tak boleh kira error. So error only start here. Okay, satu lagi Umi cakap you need to round up dulu. Dia lupa nak round up. Okay, but it's okay. Okay, so I round up for him. So yang ni jadi walaupun 41.1, you have to round up. Okay, jadi 42. Yang ni pun 41.6, round up to 42, okay? So, error dia become a round number also. Sebab 38 akan tolak 43 absolute value. Dia tak ada negatif, positif untuk error. Untuk error always positif, okay? Walaupun dia negatif sebab absolute error, absolute value, so dia akan jadi 5. Okay, do for this one, 43 tolak yang kita dah round up kan dekat error, dekat forecast tadi. And then this one, 39 tolak 42. So, kita dapat sum dia 5, 1, 3. Okay. Untuk yang soalan kedua, dia kata 2 weeks kan. 2 weeks weighted moving. So, dia bagi 2. 2 weighted. Okay, confirm betul. So, kita tahu yang 2 minggu pertama tak boleh buat forecast. Okay, sebab tak ada data sebelumnya. Hanya boleh start minggu ke 3. Okay, untuk minggu ketiga, kita dah kira again. Dia lupa nak round up kan kat sini. Okay. So, you need to round up. Okay, yang ni tak perlu. Okay, yang ni jadi 42. Yang ni tak perlu. Yang ni jadi 41. Yang ni tak perlu sebab dia dah round. So, error pun akan berubah sedikit. Yang ni tak ada perubahan. Okay. Yang ini ada perubahan. So, 45 tolak 42 dapat 3. And then yang ini. Okay. Sama. Yang ini 41 tolak 43 tolak 41. And then yang ini pun stay. 2. Okay. So, kat sini ada berapa error? Ada 1, 2, 3, 4, 5 error. So, bagikan nanti sum dengan 5. Okay. Nak tahu berapa sum ni nak bagi. Nak bagi dengan berapa error ni. Kita kena tengok berapa error ni. Bukan tengok ni. Yang ni tak ada kena-mengena. Untuk dapat MAD, MSE dan MAP, kita kena tengok ada berapa jumlah error yang wujud. Untuk dipuratakan. Okay. So, ada perubahan sikit. Kat sini tadi kita dapat kat sini sum dia 5 campur 1 campur 3, 9. So, bagi 3 sebab ada berapa error? 1, 2, 3. Okay, untuk untuk yang kedua, yang dikata 2 weeks moving average tadi, ada perubahan sikit. 2 campur 3 campur 5 campur 2 campur 2 dapat 14. Bagi berapa error? 1, 2, 3, 4, 5. So, 28. Tapi jawapannya masih menunjukkan bahawa terbaik adalah yang paling sikit. So, the best 2 weeks weighted moving average is more accurate because MAD is smaller. Yang ni yang paling accurate. Okay. So, nampak tak macam mana compare moving average biasa? Senang. Untuk weighted moving average, berhati-hati sebab you need to have the weight dulu. Okay. Ada pemberat. So, the best thing is the smallest error. Selalu kita akan kira error, kita akan compare dua method. Okay. Alright. nanti kita akan bincang this part in the live session. I will show you this calculation. And also you can try this first. Okay, nanti check the jawapan with me during the live session. And also we're going to learn this one. Okay, we're going to solve this one. This one is ada apa dia minta nampak tak ada weight kat situ? Okay, 0.1, 0.3, 0.6. So kita tahu itu adalah weighted moving average. And then dia guna kedua dia minta knife method. Lepas tu dia minta apa? Dia minta suruh kita compare error weighted moving average dengan naive. So mana nak pilih nanti? Kalau mau accurate kita akan cari MAD yang paling rendah. Okay, so we will solve this in the live session. So we have done naive, we have done moving average, we have done the exponential. Next class kita akan tengok exponential. And jangan confuse dengan tiga ni. Tiga ni adalah error. MAD, MSE, MAPE ni, MEM ni adalah error. Okay, dia adalah error. Dia bukan kaedah. Kaedah tu yang atas tu tadi. Naive, moving average, exponential and linear trend. These are the method. These are the error measurement. Error measurement ni nak measure apa? Tengok comparison antara method-method yang ada. Alright? So, I see you in the part 3 later on.